Well, we are at 6 o'clock, David. So if you want,
Okay.
I can go ahead and we can start out with this.
Okay.
There's
Hello, Cindy.
Cindy. Cindy, we haven't seen your face in a while. We miss seeing you here at the library. Cindy used to work
C-
here with us, and
yes,
she.
Cindy and I go back some. So
Okay,
good to
great.
see her. Good to see you again, Cindy.
Um, Well, I want to start by saying good evening to everyone. My name is Nathaniel. I'm the digital literacy coordinator here at Greenville County Library System. And if you're just joining us now, or if you've been on for a little while, we are having this program tonight about us landing on Mars. We're going to be doing that tomorrow, but we're here with David Lippert from he's an ambassador from NASA who's here to talk to us this evening about Mars, about what's going on with this lander. Um, as David's been saying, and as I've been saying, as we've been kind of going on, we want to invite people to feel free to ask questions. So if you want to turn on your video and unmute your microphones, you can feel free to ask questions. Otherwise, for those of you who are just going to be watching and listening, go ahead and keep yourself muted until you want to get in here and ask a question. Also, feel free to make use of the chat. You can ask questions in there if you need to type something. I'll be keeping an eye on that as we proceed this evening. But without further ado, I want to pass this off to David and let him start and tell us what he's got to tell us about Mars and this lander we've got landing tomorrow. Welcome, David.
Thank you. Thank you. Welcome everybody. And so glad you could be here tonight. And what's coming up tomorrow is just absolutely, if you just think about it for a second, it absolutely blows your mind that we can take something the size of say a Volkswagen and land it on Mars that far away and that precisely. I mean, it's just something to just blows my mind every time I think about it. Gives me makes my lots of hair now, but like makes my hair crawl on the back of my head. So it's really remarkable what's going to happen. One thing I want to note right off, as well as a lot of these missions go, the overall landing record on Mars is only 49%. So it's hard. So there's been a lot of failures on Mars. We're hoping tomorrow, let's cross our fingers, that's not the case. But this is a very, very difficult thing to do. And they make no bones about how hard it is. There's a lot that can go wrong. And I'll point out a few things that makes it even harder as we go along. But I'm going to share my screen out here. And we'll start off, and that's us. We're going to land on Mars. I really like this particular NASA photo. It starts on the left. There's the little Sojourner rover. That was the very first one that was placed on Mars back in the 90s. Then there's Spirit and Opportunity. Then there's Curiosity, which is actually running and operating today. Here's Perseverance. Part of Perseverance is we're actually going to, and more detail later, but we're actually going to return samples back to Earth from the Mars surface. And that's what this is about. And then finally, there is a person standing there to prepare for human exploration. So that's kind of where we go with that. Real quick on me, I'm name is there's David Leapart. I have 2 degrees in physics and math. Worked with NASA in Boston back in the day on I was on the aeronautical side, aviation and that sort of thing. So it was an interesting time. But currently this program that I'm a member of is based out of NASA's Jet Propulsion Laboratory, which happens to be the home of the Perseverance rover. Matter of fact, all of the rovers were developed at JPL. And this is part of the JPL outreach program that they have a lot of us around the country doing exactly what we're doing. So with that, we're going to get started. And here is kind of what we want to do today. Briefly, I want to just kind of look at Mars a little bit. The background picture is of Mars. And then what's happening tomorrow. That's the big deal. That's really what we want to really look at. So I got some of these. So here's where you get to unmute and answer for me. And that is, are there canals on Mars carrying water to parts of the planet? So has somebody gone up there and dug canals and transporting water from here? This was the heyday back in the day. Everybody thought there were canals on Mars. So are there any canals on Mars? Anybody?
If anyone's got ideas, you feel free to.
Anybody got ideas?
Free to unmute yourself.
Free to unmute.
Or post it in the chats if you want.
That's it. And really, initially, due to the very poor telescopes, this is back in the 20s and 30s, early scientists actually thought they saw water canals. And this is where the whole idea, if you think about War of the Worlds and H.G. Wells and all this stuff, is that they were saying, well, maybe there's Martians living there and they've dug these canals because their planet's dying and they need to get water from one place to another. But really, it was due to poor telescopes. I have a little video clip here that goes into this.
Not too long ago, there was a widespread belief that just like Earth, Mars was a life-sustaining planet with rivers and canals, populated by a human-like Martian species rather than being a dry, dusty land devoid of any life form. Martian belief exploded, particularly in the late 19th century when some English astronomers misinterpreted the works of the Italian astronomer Giovanni Schiaparelli, who, while observing through his early low-resolution telescope, had found a network of long, straight lines on the surface of Mars. Schiaparelli had called them canali, which is Italian for channels. English-speaking astronomers mistranslated it as canals, or more specifically, water canals, and after further observations proposed the idea that these canals were waterways built for irrigation by an intelligent civilization on Mars.
Oh, well, not. This was unproven with the first spacecraft went to Mars and returned these kind of fuzzy pictures now, but you can see in some of these, you can see craters and mountains and all. It looks, if you didn't know better, you thought you were looking at the moon. So really what we found a place that looked more like the moon than Mars. There were no evidence of any canals or any Martian cities or anything else. So Mariner 4 kind of solved that mystery. And if you look at these early pictures, let's see how far technology has come. Oh my goodness. This is now views that we have of Mars. You can see if you were looking at this through fuzzy eyes or through a very poor telescope, see the kind of light areas, dark areas, and so you could almost see where maybe your mind would start connecting the dots and you see lines. So it's probably an honest mistake. But these are the pictures now that we can that we have of Mars, thanks to a lot of spacecraft and a lot of observations and a lot of photography. Next question for you. Mars once had oceans, lakes, and streams. True or false? Unmute. Mute. Chat.
True.
True.
Mike
there we
says
go.
true.
And who was that?
That was Mike.
Mike. Thank you, Mike. And
Mike West.
Mike West. Hello, Mike West. And the answer is absolutely correct. It once had, and we'll see even more, streams and water. Was a very much a water planet. At one point, they believe they had as much water, if not more, than Earth has today. Lots of water. But today, it's rocky and cold beneath a hazy pink sky. So you can see this picture. I believe this was from Opportunity. This is typically Mars, rocky, dusty, got its pink sky, and we believe there's water, but scant amount of water at this point. But a lot of the lake streams and oceans are gone. However, let's look at sunset on Mars. On the left, beautiful sunset here on Earth. You see all your pinks and your reds and your typical sunset colors. Beautiful. Look at the sunset on Mars on the right. You know you're not in Kansas anymore. And that is because the atmosphere of Mars is mostly carbon dioxide. Carbon dioxide, opposite from the Earth's atmosphere, actually absorbs the red and passes the blue. Ours absorbs the blue and passes the red at sunset. So you get a different kind of sunsets. You get a blue sunset on Mars. I like this particular photograph. It shows one sun, but two different spots, one here, one on Mars. Okay, next question. You didn't know you was going to get a quiz tonight, did you? Mars is a very large planet, is really the same size as Earth and Venus. Is that true or false?
That's false.
That's false. That sounds like Mike still. Wonderful. And
Yep.
the answer is yes. If you look, Mars really is quite small. It would take 6 Mars to actually fill the Earth. That's how small it is, very small. Since Mars now has no water, Earth does, the landmass, however, of Mars is about the same as the exposed landmass now on Earth. So that gives you a sense of how much exploring we can do, but the actual size of the planet is really quite small, which therefore translates into gravity, just like you saw the astronauts jumping around on the moon. If you watch my little astronaut guy on the Earth on the left, look what happens when he gets to Mars. So it's 62% less gravity. So you weigh a whole lot less, so you can jump a whole lot higher, which really has helped in scientific research, because when meteors and meteorites hit the Mars surface and explode the surface and blow out rock, since the lower gravity, some of that rock just keeps going and goes out, and some of those have actually found their way to Earth as meteors, as shooting star. And so we've been able to actually get pieces of Mars as a meteorite. And they're extremely valuable because there's a lot of information there. But the only problem is they did go through the atmosphere and got kind of cooked. So it's not pristine. It's not like going to Mars and taking a shovel and saying, hey, look, I have a sample of Mars. It's a little different, but valuable just the same. Next question. 1 year on Mars is about 2 years on Earth. True or false?
I'm going to go with true on that too.
True. Okay. Here we go. A year on Mars is almost twice as long on Earth, with 365 here, 687 on Mars. Because they're further away from the sun, orbit's a little slower, so it takes 687. So if you don't like winter on Earth, you won't like it on Mars. It's going to be about twice as long. So that may not be, but if you don't like hot summers, same problem. So maybe if you could find a nice spring spot. But anyway, let's get on that. I think that I just wanted to review a little bit about Mars. Any particular questions there on that? As there is a real fast, quick review of Mars. Okay. Well, tomorrow is the big deal. A new rover lands on Mars. And I'm going to unveil a picture here of the new rover. This is not the one that most people have seen, but I got this through a secret channel, and we are going to see it for the first time tonight. There he is, rover. See the little wheels and sitting there. The only problem, we got to get him food somehow. No, not really. Anyway, I kind of like that. I kind of like that picture. Even has this little NASA logo on there, huh? So that's not the rover that's landing tomorrow. I think he looks like he's somewhere out west. This is the rover that's landing tomorrow. It was for the longest time called Mars 2020 because it was launched in 2020. It was named by a 7th grader. NASA did a naming contest, and he called it Perseverance, and they chose that name, which turned out to be a good name, especially in light of COVID and everything else going on. It's a good name. But this is the rover. You can see it has 6 wheels. It's a little bit bigger than Curiosity. And these are the various, and we'll go through a little bit of this, but these are some of the instruments that are on the Perseverance lander. The big one, and you'll see in a minute, is called Sherlock. And there's no mistake, there's a camera that goes with it called Watson. So we know where that came from. But this arm and this instrumentation here are really some of the key parts of the rover, because the main objective of the rover is to look for past signs of life. I'll say fossils, but we need to be real careful with that with that word. But it's looking for actual past forms, not organic compounds, but actual past evidence of life. Some of the other instrumentation is a weather station, because that's extremely important on Mars. Just like on Earth, we need to know the wind speed, wind direction, and especially dust. What's the level of dust in there? Because they have some massive dust storms. Matter of fact, it took out the Opportunity rover with its solar panels. Cameras here, it's SuperCam is going to actually have the ability to, at a distance, determine if a rock at a distance has interesting makeup and organic compounds in it. It was developed in Los Alamos, New Mexico. Mastcam Z is, I don't know if you can see them or not, but it's like a ViewMaster project viewer. There's two separated cameras, so they get stereo. And the Z stands for zoom. They're going to be able to zoom in, so they'll be able, in stereo, the rover will be able to see exactly where it is, where it's going in 3D. So that's very, very helpful. REMFAX is a subsurface radar, so it'll be penetrating the ground to find out what the structure underneath the rover is. A big deal here, this is a technology advancement experiment called MOXIE. And what they're going to do, since the Martian atmosphere is mostly carbon dioxide, CO2, they're going to do reverse, where they're going to kind of make it like a person. It's going to, a plant. They're going to take in the CO2 and split it apart and produce oxygen. The big deal here is when we send people to Mars, this would be a good way to produce oxygen, which is handy. And also oxygen is a wonderful rocket fuel. So it's a way to actually create oxygen on Mars itself. So that's an experiment here to see how that's done. That's done at my old stomping grounds up at MIT in Boston. Okay, I kind of given it away, but there it is, Mars 2020 Perseverance rover. And again, this is the big deal here, is the arm extension with a lot of instrumentation on that. Where it's landing. Now, this is something that a place they wanted to land a long time ago on other rovers, but they simply did not have the technology to place it there, because this is a very, very dangerous place to land. Lots of cliffs, boulders, craters. It's not a smooth parking lot. So we just simply did not have, even with the last rover, Curiosity, we still did not have the technology to place it well enough such that it didn't come down on top of a boulder and destroy itself. But we believe we're there now with the Perseverance rover, so we're going to go for the Gusto and go to Jezero Crater, which is here in red. You can see a few other spots. Here's where the Opportunity rover landed. The Vikings landed in here. The Phoenix, Spirit way over here, Viking 2. And why do we want to go here? This is a picture that is a photograph. If you could go way back in time, billions of years, and take a picture of Jezero Crater, it would be called Jezero Lake, because it was a crater that was full of water, about the size of Lake Tahoe. And the X I've put on here is where we want to land. And you go, why in the world are we going to dump the rover into the middle of this lake and sink it to the bottom? No, because today there's no water. This is Jezero Crater today. And I'm going to go back one slide. This is, you can see there's water coming in. This is an inlet into this lake back here. And in the lake, and then over here was an outlet. The water was actually running out this way. So it's kind of like, typical lakes here on Earth. So there's an inlet and an outlet. We want to land near this inlet, because in any river situation, I have better pictures. This is the inlet that exists today. You can see where it kind of comes through here, breaks through the wall, and there's a river delta. If you've ever seen the Mississippi River Delta, it kind of looks like this. And that's going to be all kinds of mud and everything else coming into the crater, into this lake from this river. Wonderful place for small microbes or microbial life or whatever to actually be in this water and be lodged in this delta. X again is where we want to land. You can see there's cliffs here, and this is all not shown so much here, but there's all kinds of boulders and whatever else here. So it's a very tough place to land. As a quick note, we're calling this Jezero crater. You'll hear that, especially tomorrow on the NASA live feed. But just as a little trivia for you, it's not called Jezero. It's Jezero. It's Bosnian. What NASA did is they went through and named a lot of these significant craters for small villages in Europe. And this is a small village in Bosnia. So that's how it got its name. And then in that language, Jezero or Jezero means lake. So a little trivia for you. Here's a little better picture of that delta. So you can see we want to land out here. We're above where it says clay and carbonates. There's the cliffs here. Here's where the inlet, it broke through the crater wall, and you can see the water flow. A lot of water flow here and across here. A crater hit it later in time. But imagine all of the mud and muck that was basically sitting here, and we really feel that if, where there's water, the old cliche, where there's water, there's life. If there was life, this would be an excellent place to go look for it. And you can see the scale down here, about 2 kilometers. So it's a relatively big place. So that's the why here, is that it's a river delta, perfect place to look for microbes. So what are we going to do? What is the rover going to do on Mars? Here's a little video clip, I think, that really talks about that in a very good way.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second 2 missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
Okay. Hopefully that helped a little bit. I think that was one of the better clips that I've seen. Okay, let me see. Let me get back to my... Yep, there was the rover. Okay, let's get into what happens tomorrow. This is the big deal. This is the most dangerous part of this whole mission, is trying to get this thing on the ground. So what happens tomorrow? We have this rover and we launched it and it's flying through space, and we got to somehow get it onto the surface of Mars and get it through the atmosphere, etc. So what does that look like? Does it look like that? No. I made this up. The rover's not flying through space as the rover itself. It doesn't look like that. It doesn't have a rocket on the bottom of it. We have to package up the rover and put it in a little package in order to safely get it through space on the journey to Mars, and then have it kind of unpackage itself and do the reentry and all. So we're going to go through that. This is what it looks like going through space. And you go, that doesn't look a thing like a rover. What in the world is this mess? Nope. And you're right, it does not. This is called a cruise configuration for the rover to just get it to Mars. I'm going to break it apart for you here. This top part is really just the solar panels. This is kind of a unit with electronics and solar energy, etc., battery pack, all of this to service the rover and this instrumentation as it travels to Mars. This is called the back shell. It's kind of, upside down teacup that sits over the top of the rover. This is the rover back up. This is the back shell. This sits over what's called the descent stage. You notice the rockets on here. You'll see in a second what these rockets will be doing. So this is the descent stage. Here's the rover, all folded up. You can see the wheels and all, so it's kind of all crunched up together. And then a heat shield, because Mars does have an atmosphere just like the Earth. Now, it's not real thick. Compared to Earth, its atmosphere is only 1% of what the Earth's atmosphere is. So you would have a very hard time going there and breathing because of the pressure, and also it's carbon dioxide anyway, but it's just not very thick. But it's thick enough that we still have to use a heat shield, just like a lot of the spacecraft that come back into Earth, Apollo, SpaceX, etc. They have to re-enter and use the friction of the atmosphere to slow down. So it's enough to still do that, but not enough to slow it down to the point where it can do a soft landing. So this is the cruise configuration spacecraft. I'm going to back up one more. I'm going to put it back together for you. And so there it is when it's all put together. There's the solar panels, the back shell, the descent stage is in there. The rover is tucked up under here, and here is your heat shield. So that's where we start tomorrow. And here's the sequence. They call this the 7 minutes of terror. It takes 7 minutes to get from the top to the bottom where the rover is sitting on the surface. 7 minutes. You're starting at 12,000 miles per hour at this point, and you're going to 2 miles an hour at this point. Oh my goodness. How would you like to do that on the interstate? Go from 12,000 to 2 in 7 minutes and survive. Quite a feat. And this is what I was talking about before. This is why landing on Mars is so hard, and why they call this the 7 minutes of terror. People don't like the word terror. They say it sounds like a horror movie. Well, no, if you talk to the people that are actually on this team, it's 7 minutes of terror. So let's walk through it real quick here. We've got around 10 minutes before landing on the surface. You're coming in, and here's the cruise configuration we just saw. It's starting to make its descent. This very top piece with the solar panels and all that stuff is ejected, and you're left with the back shell, the heat shield, and the rover that's inside. So here it's now starting to hit the atmosphere, the outer edges of the atmosphere. And so it's coming in, and you're starting to get the heating from the speed it's coming in. And you can start to see here it's got shown as glow, but it starts to heat up. The heat shield in this phase will actually go up to about 2,000 degrees. Quite hot. But it's at the same time, it's also slowing down. Once it gets through this phase and it's slowed down enough where this sort of abates and the heat kind of goes off, now you're in what's called guided entry. There's actually little rocket thrusters on this piece of it here that can kind of move it and guide it because it's still trying to get to this particular landing spot. We're still going supersonic. We're still going around 1,000 miles per hour at this point, though. Still quite fast. So we still need to slow this thing down. And so the next way to slow it down, we've already done some slowing here. The next thing to slow it down is we're going to eject and blow out a 70-foot parachute, which sounds simple if you're a skydiver or whatever, but we're doing this at 1,000 miles per hour supersonic. When NASA started first trying to do this, excuse me, I can't tell you how many parachutes they tore up. It's not easy going out at 1,000 miles an hour and not tear the chute up. So this is a very special situation where there's a lot of research went in to be able to do this where the thing's just not ripped off. Hopefully tomorrow, all of that's going to pay off. Now, some of this we borrowed from Curiosity, so we feel pretty good about it, but we're going a little faster here than we were with Curiosity. So we had to beef this up even more. Now we're through the heating of the atmosphere. We're going to, right here, we're going to drop the heat shield. We don't need that anymore. Now we have the back shelling. Start to see a little bit of the rover in here, and we're still on the parachute. Now kicks in the newest piece of technology, which is completely new from Curiosity and any other landing, and why we can go to Yezero or Jezero crater. And that is two items. One is radar. We have a much improved radar system so that now the rover is exposed. It's using radar to actually look down at the surface and figure out how fast it's going, how high it is, et cetera. So it gets a really good feel for what's going on and where it is. Again, we still have the parachute at this point. Now becomes the really big piece of technology that's going to be really important, and that's called terrain relative navigation. You'll hear it tomorrow. They'll refer to it as TRN. When they say TRN, they're talking about this terrain relative navigation. Now, this is slick. This is really slick. You'll see here the little trapezoid here. What it's doing is it actually has really high resolution cameras. It's going to start taking pictures of the surface of the planet surface, which you say, well, that's nice. I'm going to send them home to his parents on a postcard. No, these aren't tourist pictures. He's going to be taking those pictures, and then Perseverance is going to have an actual photos, or call them maps, photo maps that have been put together through orbiters that have been taking photos, all kinds of sources of photos, so that they know pretty much, 99.9%, they've got the surface identified in these photo maps. The slick part about Perseverance is it's going to take its photos that it takes itself, compare it to the photo maps and say, okay, am I really am where I think I am? And then start to compare the two. And then once it gets those two locked in, it knows exactly where it is. Then the next step is on those photo maps are marked all what's quote unquote the safe landing places. So it's going to have a choice. Safe land. Oh, I got one. I can land here. I can land here. I can land here, here, here. And it knows exactly where they are because it knows exactly where it is. It's going to pick the closest safe landing place, and that's where it's going to try to go. Based on that, next step is we eject this back shell, gone with the parachute. Poof. The descent stage and the rover are now together. The descent stage then fires. Those are those rockets I showed you earlier. So now it's actually flying. And based on the photo maps and its navigation, it's going to fly to that safest place to land that was identified on those photo maps. So here we go, boom, 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 it's flying, etc. It comes down. Then it's going to come down, and as it gets closer to the ground, it knows where it is because of radar, so it knows not to crash into the ground. It's going to kind of what I'd call hover for a second. Then it's going to actually, on cables, it's going to lower the rover down to the surface. And when it detects that the surface and that the rover is actually sitting on the surface, the rover actually ejects these cables. The descent stage says, okay, my job is done. It then flies off because it doesn't want to crash down on the top of the rover. It flies off somewhere and boom, crashes into something, but we don't want it crashing into the rover. And at that point, then the rover is sitting on the ground, and when it comes down on the ground and lowers down on these cables, it bumps into the ground at 2 miles per hour. So that's, so now you kind of see where this is very, very difficult. Just all of this has got to happen. Now, the next thing that even amplifies that like mad is the fact that Earth has nothing to do with this. In order to get a signal to Mars, from Earth to Mars, or to the rover or back shell or whatever, it's 11 minutes. So if I say on Earth, I say, hello, 11 minutes later, the rover would hear, hello. You can't fly a spacecraft with an 11-minute lag. And then it's going to take 11 minutes for the rover to respond back saying, I heard you. Doesn't work. So what that means then is all of this is done autonomously. The rover is on its own. It figures out and does this all by itself, from this top part all the way down to the bottom. And so we're sitting on Earth in the controller, in mission control, and that's why they call it the 7 minutes of terror, because they have no idea whether this is going to work. It's autonomous. They can't do a thing about it. Now, there's one thing up till about right here that the rover can actually talk. The Earth will be up about right in this area. The rover will be able to send what's called direct signal beeps. It's like 256 tones, like off a piano keyboard. Bum, 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 bum. And when we hear a particular tone, that tone means this event has occurred. So that's about all we're going to know. We might hear the tone, let's say back here, bing. Oh, that's the tone meaning the heat shield is falling off. Great. If we stop hearing tones, that's not good. But then right about here, the Earth has set below the horizon and we lose all connectivity with the rover. So we have no idea. So all of this comes down by itself. And from that point forward, communications with the rover back to Earth is done via the orbiting Mars Reconnaissance Observatory, what's called MRO. You'll probably hear that tomorrow. That's orbiting around Mars taking pictures, but it's also a relay station for the rover. So the rover will be communicating through MRO, and there's another satellite called Odyssey, but it's not quite as capable as MRO. Is a very high-speed relay station, so we'll get a lot more information from there. Okay, that was a lot. Any questions? Any questions so far?
David, we had one question. Scarlett asked if there was a backup parachute in case something happened with the first parachute.
Wouldn't that be great? Sorry, Scarlett. If this one fails, we're dead. There is no backup. There's simply not enough room, space, weight, etc. There was no room for a backup. So the way this actually works is I've seen demonstrations of this parachute is there's not real complicated on ejecting the parachute back at this point. When it's time, you want to actually knock the parachute as a mortar, just like in the military. I mean, it's exploded with a cannon, actually blows this thing out. The parachute is actually folded and tucked into a ball about as big as my fist. And it's so hard you can knock on it. I mean, it's really solidly packed. Mortar blows this thing out. And then I think in half a second, from the time it goes out, in about 0.6 of a second to be exact, it goes from that curled up ball to 70 feet. Poof. Because remember, we're going 1,000 miles an hour. So it doesn't take long for this thing to go poof and expand out. So nope, there's no backup. I see Mike's, and you're exactly right. The good news is that if they're irritated, we hope to hear from them, because that would help us with our search for life. But it's I think the question had even been asked at one of the news conferences, rather it just flies away and unfortunately crashes. In the future, what they're looking for is actually not to crash, but have enough fuel and enough capability to actually just land, but not this time. Okay. Any other questions before we go on?
Yes.
Yes.
So, I have a few questions actually.
Sure.
Is there any backup rovers?
No, it's just the one rover. Perseverance is all by its lonesome. So if it crashes, we're dead. There is no backup.
And is another rover gonna land soon?
Well, as a matter of fact, it will. Nathaniel and I were talking about this way back before the meeting got started, is that this is a very crazy time at Mars right now, is that we're sending Perseverance. The United Arab Emirates, UAE, also just last week entered one of their spacecraft into orbit around Mars to do climate research. The Chinese, Tianyuan-1, also went into orbit around Mars last week. And the last I heard is maybe summer or fall. It's still a little fuzzy. They're going to send a rover down to the surface, not near Perseverance, but a different spot. But they're going to send a rover down. So the Chinese are expected to have a rover on the surface of Mars before the end of the year. So you're absolutely correct.
Cool.
Yay. Okay.
David, another question that kind of goes along actually with what you were just talking about. And Megan asked how long it took for this trip to get from Earth to Mars this time.
It's there's two parts to that. It's about 8 months, about 8.5 months. And the big reason that it's 8.5 months and maybe not a year or a year and a half is that you launch when Mars and Earth are just such that it's going to take the shortest time to get there. And that alignment came back in July. So we launched Perseverance in mid-July, and we took the quickest route to Mars, which is about 8 months. So it's no coincidence that China and UAE also launched their spacecraft at the same time. So we're all three arriving is because that was the best time to launch and not take so long to get there. One of the advantages of trying to get there as quickly as possible is that along the way, when you're traveling to Mars, you may have to fire your rockets to kind of correct your trajectory, and that uses up rocket fuel. So if you up there the shortest amount of time possible, the less rocket fuel you use. And the less rocket fuel you use means there's more available when you go through the 7 minutes of terror. So that's another advantage of doing that. Okay. Any other questions before we go on? This is the critical part, and this is what's going to happen tomorrow.
I think the last question we have in the chat right now is Mary
Okay.
asked, how long did it take NASA to kind of plan and implement this whole, when did they start kind of planning this mission?
It's it started back in the 90s with Sojourner, so it's been a path of learning and building. So you had Sojourner, and then Spirit Opportunity, and then you had Curiosity, and so that each one is built on each other. As far as Perseverance or Mars 2020, it's around 10 years. So a lot of the research goes back. A lot of these folks that have been working on this have been working on it pretty much a decade to get it to this point, which I guess gives you an idea how complicated it is. It's not something you can do in a week. This is not a weekend project. It's about 10 years. It's on a lot of these, there's a number of scientists at JPL who started really with the first rover, Sojourner, and they're still there and they're working on Perseverance. This is all they've done. Their whole career, 30 years, has been working on these rovers. So their whole career has been involved with doing the research and the science involved around this. This is all they've done. They've worked for NASA for all that time in this area. They love it, obviously. Okay, so we'll go on. So I got a little video clip. Now this is we kind of walk through that so I could kind of talk you through it, but now I have a couple of videos here and you'll be able to now see it more in animation as exactly kind of what's happened. So they're good clips.
During that entry, it's got to survive the intense heating and deceleration of that period, while also using thrusters to steer toward the landing target to make sure we go to the right place. After slowing down to supersonic speeds, Perseverance will deploy a large 70-foot diameter parachute while still traveling almost twice the speed of sound. That'll slow the spacecraft down even further. While coming down on the parachute, Perseverance needs to figure out where it is. To do that, it'll jettison the heat shield that protected us during entry, and it'll use a radar and a new system we call terrain relative navigation to help figure out where it is. But the parachute alone isn't enough to slow down Perseverance for landing. In fact, the spacecraft is still going more than 160 miles per hour when the parachute is done, slowing it down. That's about as fast as a skydiver would be going if he jumped out of a plane here on Earth and headed straight for the ground head down without a parachute. So at an altitude of a little over a mile or so, Perseverance will fire up its engines, fly to a safe spot identified by that terrain relative navigation system, and slow down to about 1.5 miles per hour right above it. And then it's ready for sky crane. Perseverance will lower itself, much like Curiosity did, from that rocket-powered jetpack descent stage and maneuver in for a gentle touchdown right on its wheels.
That was the voice of Al Chen. He is the head of what's called the EDL team, or Entry, Descent, and Landing team. They're having probably a sleepless night. But Al is a really neat guy, and we will see him tomorrow. But Al, I got that little piece from Al narrating kind of what I did to kind of repeat that for you. Okay, this is really slick. How about that? That's what's going to happen tomorrow. And again, the big deal there is it does it all by itself. There's nobody on a joystick. So that's kind of, I wanted to leave a few minutes for questions, discussion, or whatever. The big deal, if you can, join us at 2:45 tomorrow. If you haven't registered yet, Nathaniel can help you with that. For me, my NASA email address for here in Greenville is Greenville. This is greenvillenasa@gmail. If you have any comments, questions, suggestions on this or anything else, there you go. Please send me an email. I'd love to hear from you. There's one other video I'd like to show that I think, who is it that asked about the drone or the helicopter? Who was that?
Go back and see. That was back in the discussion, way back in there. Believe that.
I don't know. It may have been me.
Oh,
Yeah.
okay.
Catherine, that was.
Okay. Well, I have a little video clip for you. Would you like to see it?
I would love to.
Here we go. Okay.
Oh, wow.
This is really slick. There it is. It's about 3 feet across. So it's big. Has 2 cameras on it. How about that?
Yeah.
It's like I say, it's big. It's about 3 feet. And there's a lot of research went in that. A lot of the aeronautical people got involved because it's basically a reverse rotating helicopter. You have to have the two going against each other because, in a typical helicopter, you have where the people sit and you have the big blades, above you. And then on the tail, you have that smaller rotor going around. So that keeps the helicopter from doing this. Well, we don't have a tail. So they did these rotors go in opposite directions, and so that keeps it stable. So that's the reason they're going in opposite directions. And then all of the electronics for this are in that little small box underneath the rotors. And a thing they like to point out, this team does, is that the helicopter is completely autonomous. Once the rover, it lowers itself out of the bottom of the rover, which is where it's been carried, and the rover moves away, it's on its own. It has to do all its communication. It has to keep itself warm at night. It has to do all of that, and there's a pretty sophisticated amount of computing going on inside that little guy. So he's very, very powerful. 2 cameras on the bottom. So the whole big deal here is it's a technology demonstration. I mean, they're not getting any real science out of the helicopter per se on this mission. But if you think about if this really develops into a really good technology and it can get more instrumentation on the helicopter, maybe make it a little bigger, it can go places that the rover can't. The rover can't go to like in this picture, rover can't climb to the top of this mountain, can't really go down to the bottom of this crater, but the drone could. So it would really open up places and areas that you could explore in Mars or whatever else. The next application of this is going to be on the moon Titan, which is out with Saturn. And Titan has an atmosphere even thicker than Earth's, and there you can't land on it. Whatever you land lasts maybe 2 minutes, then it's crushed. So they're going to actually have drones like this a mission called Dragonfly. Dragonfly will be the mission to Titan to explore the moon of Titan. One thing that, and I'm sure you probably already know this, for any more information on any of this stuff, make sure you can always go to nasa.gov, G-O-V, And anything and everything is out there on any of this. So that's a good resource. Let's see, we have about 5 minutes. I have a couple of extra slides here that I can show you. I'm going to go. This is kind of the, when they take these samples, the whole idea is that they're going to drill down and they're going to be about the size of a test tube. And then they'll have the sample in that test tube. When they get enough of them together and say, okay, we have a good sample, they'll drop them on the surface. And you can see that's kind of what's going here. They're going to take samples. They'll end up putting some here, come back, drop some more, drop some more. Then the Earth return mission that's going to be launching in the late 20s will come down, send a little rover down, not as sophisticated as Perseverance. Really, its job is to go get these things, pick up these sample tubes, take it back to a lander, insert them into essentially a rocket. That rocket's going to launch off the surface of Mars and go up and meet an orbiter that's around Mars, and they're going to bring those tubes back to Earth. And I think he mentioned like early 2030s to actually get those materials back. So that's kind of an idea of where they're going to go. You can see they're trying to cover the delta first, but then try to get up into the mountains on those dotted lines as an extended mission. This is, yes.
The SpaceX astronauts will be able to just pick those things up and bring them back much sooner, I expect.
Yeah, yeah. They want to make sure they put a zippered thing on their suits because we don't want to lose them.
Right. Okay. I actually have a couple of questions, or a question and an observation. My first question, please pardon my stupendous ignorance on this, but what was the launch vehicle?
The launch vehicle was an Atlas. It was a ULA Atlas. Atlas with, I believe, it may have been 4 solids, but it was it busted it. Yeah, it was a ULA Atlas. I'm pretty sure, if I think about it, had 4 solid boosters on it. So it launched back in July from the Cape.
Okay. My next question, which is, like I said, an observation, because we're talking about manned missions to Mars and the duration that it will take for the spacecraft to actually arrive on Mars. Yep. Now, I expect that you and I might be the only couple of people in this crowd who remember Project Orion. Not the NASA Project Orion, but you know which one whereof I speak, that detonated, used thermonuclear devices as its propellant, basically.
Right.
And the word on the street is they could get there in about 3 weeks using such a system.
Yeah, theoretically, you're right. What they've got to do is perfect that. And the speaking is, when the manned or human missions to Mars do come about, it will definitely involve probably what would be called ion propulsion. Same idea. In order to do that, you can go quite fast with ion propulsion. Ion propulsion, instead of blowing fire out of the back of a rocket, chemical, which is not that efficient, really. It works, and you can get a lot of power out of it, but it's over quick because you burn it up really fast. Ion propulsion shoots ions, or it could be water, ionized water, out the back of a rocket, and it's shooting these hot ions out the back of a rocket. The amount of thrust is quite small, but the big deal is it's constant. It goes and goes and goes, and pretty soon you are really moving it. So they're looking at propulsion out to the outer parts of the outer parts of the solar system is more than likely going to be ion propulsion. Now, some of this was actually, if you go to nasa.gov and pull up the Dawn mission, like Dawn Liquid Detergent, DAWN, and look at that mission that went to Vesta and Ceres, 2 of the big giant asteroids out beyond Mars. It was one of the first to use nothing but ion propulsion. Worked like a champ. It was fantastic. It was able to maneuver and do all these crazy things because it was using the ion propulsion. So that's a big deal. That's a big deal. So that would be well worthwhile to go look at the Dawn mission.
David, we had a question
okay.
earlier. how long this Perseverance mission is planned to last?
Planned to last. It's planned to last 1 Mars year. And as we saw earlier, that's about 2 Earth years. That's the mission time. Now, let's say, for instance, let's look at Opportunity, one of the other rovers. It had, if I'm not mistaken, it had a 90-day mission. It was supposed to go up and last 90 days and do all these things. It lasted almost 15 years. So that's just how well these things, they engineer these things to the hilt, because once it's gone, and everything is redundant, and it's just well engineered. And so Perseverance will probably be there for quite a while, very active. Curiosity, same boat, way beyond its primary mission. But the actual official mission on paper is 2 Earth years.
The rover is powered by, if I'm correct from what I was reading recently, it's powered by a nuclear power.
Yeah, plutonium.
Plutonium, okay.
About 11 pounds of plutonium, which is good, because at Mars you're getting pretty far away to depend on solar cells. You can do it. Opportunity and Spirit did it, but you see what happened, if you remember, when Opportunity finally died. Because of the massive dust storm that happened, which happens on Mars planet-wide. And it so coated down the solar cells that it couldn't get any sunlight, therefore it got no power, therefore it died. Where Curiosity also has a nuclear power pack, it just sat there. They just kind of stopped and let the dust storm settle, but they were actually able to monitor the dust storm, and with the cameras actually look at it and take the readings, and it just sailed right through it because it wasn't dependent on the solar cells. And if you let me do here real quick, I'm gonna stop this share, and I'm gonna do a share over here. There is the rover. Okay, and what I can do, I'm taking my mouse, I can move it around. If you want to do this, you see where I am. I'm at nasa.gov Mars 2020 spacecraft rover. And I can do this, and I'm going to come around to the back, and right there is the power pack. You see it sitting off the back? If you click on it, it'll tell you about it. So there's the power pack sitting on the back. And then I'm going to go around, because I did want to show you this. There's the drill, and there's Sherlock. Sherlock is the fine scale imaging technology. That's the technology that really is looking for fossilized life of long ago. That's the main instrument. Brand new technology, never been on Mars. They're using a thing called Raman spectroscopy for what it's worth. But this is the instrument that's really the big deal on Perseverance. Okay. What else? Any other questions? If you're tuning in tomorrow, I'll go over one more time the sequence of events, but tomorrow will be an exciting day. We'll have the NASA live feed, and they'll also be telling us what's going on. And hopefully by this time tomorrow, we will be sitting on Mars with the Perseverance going through self-checks.
Yeah, this is great, David. This was awesome, and thank you so much for doing this tonight. This is Nathaniel again from the library, just for y'all who are still with us so far. And again, you can join us tomorrow. We will start we will be starting at 2:45 in the afternoon. So if you're free, and David, remind me, the landing sequence is going to be taking place about 45 minutes, an hour later.
Yeah, it's right now it's looking about 3:45. So we'll have about an hour to kind of review some things, and then we'll cut in the actual NASA feed starts around 2 o'clock. So I'll kind of watch it, and we'll cut in and out of that a little bit.
Great.
And then once it starts to about 10 minutes prior, when it really starts, that's when that cruise configuration starts getting into the atmosphere. We'll go over to the NASA live feed, and I'm gonna give you some clues tomorrow to listen to when the mission control people start giving you, they're calling out different commands, different statuses. I'm gonna give you 3 statuses, 3 to listen for, and then I'll tell you what they mean. They're code. The public doesn't know what they mean, but we will know what they mean, and we'll know what's going on before the public knows what's going on or how things are going. So we'll cover that tomorrow.
Well, that'll be great. Well, we certainly look forward to seeing all of y'all tomorrow. And again, we hope you enjoyed this tonight. I did post a link into the chat, just linking out to some of our other adult programs we have coming up throughout the library system. If you're interested in them, we have both adult and youth programs virtual right now. So please check those out. Feel free to register them. Again, David, thank you for your time tonight and being here with us. And we look forward to hearing from you tomorrow. And again, thank you everybody for joining us this evening. We sure appreciate it. We hope you have a good evening.
Thank you. Have a good
Thanks,
evening. Have a good